All right, welcome back to Unit 7 for AP Environmental Science, all about air pollution. This is our 5th video, and in this video we'll be looking at indoor air pollutants. So, air pollution, indoor air pollution is a very, very important health concern. In this image here, you can kind of get an idea of some of the important information about the air inside your home. So in a single year, a 6-room house collects about 40 pounds of dust, which could be laced with up to 45 toxic chemicals. Water damage, of course, is an issue. Asthma is the leading chronic disease in children. I'm sure many of you watching this video right now, in fact, have some form of asthma. Maybe not all of you, maybe not most of you, but there are certainly some of you or many of you. 28% of American homes are rated as unhealthy, or that are rated as unhealthy, have problems with mold, mildew, and or rot. And people typically spend about 90% of their time indoors, where pollutants can be 2 to 5 times higher than outdoor levels. And women who work from home every day have a 54% higher death rate from cancer than those who work outside the home. And this is all linked to indoor air pollution. So some natural sources of indoor air pollutants come from radon, mold, and dust. I'm sure you've seen some mold and mildew in your home at some point, or you've seen it in someone's home. And these are things that really can be prevented with just general cleaning and good building techniques. So we'll talk a little bit more about radon and why radon is, where radon comes from. So radon 222 is the most stable isotope and has a half-life of about 4 days. It naturally occurs and is a radioactive gas, and it's produced by the decay of uranium in rocks and soils. Now, the risk, of course, comes from uranium, of course, breaking down into radium and eventually radon, and that radon can get into your home. So radon will move up through the soil and enter in your basement or cracks in the walls, and it can actually dissolve in groundwater that then can enter the home through a wall. So radon can enter your home in many different ways. And radon really depends on where you're looking as far as the United States goes on where those risks are higher. So just to keep an idea, when they test for radon, that's the really only way to know if there's a lot of radon in your home. It's measured in picocuries per liter. If you guys remember when we talked about half-lives, we looked at curies as a measurement of radioactivity. Radon comes from many different sources, and they can actually test for it based on, using your home. You can do it yourself, or you can have someone come in. This is just an idea of the testing to know how high the radon levels are. Usually about 1 is about the equivalent of 2.5 cigarettes a day. It's not good. It's the number 2 cause of lung cancer, right behind smoking. Typically, if you hit a radon level of 2.7 or higher, the WHO recommends that there is some action done to reduce the radon level. And then the 4.0 is the EPA's recommended action level. And this is what would be the equivalent of about 100 chest x-rays. And typically a hospital only lets you have 4 per year. So it's the number 1 environmental cause of cancer deaths and the number 2 cause of lung cancer, remember, right behind smoking. And having that combination can give you a 10 times more risk of lung cancer if you live in a home with high radon levels and smoking in the home. Some anthropogenic risks come from insulation. And this graph here shows you all of the different types of insulation and their risk level, also compared to the money that it costs. Lead can also be a pollutant from paint, as well as volatile organic compounds, VOCs, like formaldehyde from building materials, furniture, upholstery, and carpeting. Remember, formaldehyde is not only found in, the preservation of dead bodies, but also in many different building materials. So carpeting is actually one of the big sources of VOCs. Now, formaldehyde is a natural part of our world. It's made by our bodies. It occurs naturally. This was given to us here from the Kitchen Cabinet Manufacturers Association. Right? Formaldehyde can be found in the trees where you play, so it's okay. It's natural. Just remember that typically those levels are going to be much lower than what you're going to find in building materials. Some other sources of indoor air pollution come from combustion. You can have carbon monoxide, NOx, and sulfur dioxide, as well as particulate matter and tobacco smoke. So these are just some of those sources, or some more of those sources of the indoor air pollutants. Now, in developing countries, there's more burning of wood, charcoal, dung, crop residues, and coals, and so they're going to typically have more indoor air pollution than a developed country. And for the most part, the poor are the ones that suffer the greatest risk. A good example of that is just looking at the deaths from indoor smoke from solid fuels. You can see the areas that are in red and dark red. These are areas where those numbers are going to be higher, and they also just happen to be the areas where we have more poor individuals. These are developing countries. As far as by region, household air pollution deaths have been on a slow decline down, but you can see from the different areas, North America is one of the smallest, South Asia would be one of the largest, but overall in the world the number is going down, and a huge part of that has come from right here, which you can see, which is East Asia. A lot of the other ones have kind of been steady. South Asia has gone down significantly, but these numbers are still way too high for us to be comfortable, I think. So in a developed country, indoor air pollution is a bigger problem than outdoor air pollution. The reason for that is because 11 of the common air pollutants are higher indoors than outdoors. It's greater in vehicles than outside, and the health risks are magnified because people spend 90% of their time indoors or in cars. So it's really important to understand that the more time you spend indoors, the more risks you're going to have with indoor air pollution. So that's going to lead us to what's called sick building syndrome, which is just different health concerns that come from being in a building that has poor indoor air quality. And so everyone inside the building, and especially those who spend a long time in the building, start to succumb to these symptoms. It's most common in buildings like offices and schools. So, if people start asking, well, why do you guys go on so many field trips in environmental science? Say, well, we're just trying to get away from sick building syndrome. Of course, we're trying to do other things, but some of the symptoms are here. But this is something that, is really a new world problem because of indoor air pollution. So that brings us to the end of our 5th video all about indoor air pollution. Our next is going to be talking about the reduction of air pollutants. So we'll try to see if we can get a little more optimistic.